1010 data caches results based on its transformational query language and the trillion-row spreadsheet's step-by-step workflow. Each step in the analysis is a transformation of the data and builds on previous states, making it easy to cache incremental results for reuse. Let's see how this query would be created using the trillion-row spreadsheet. Our base tag tells us which table to use. Here we'll use a retail transaction table for a line item view of store sales. Next, we select records where the store field has a value of 108, followed by records for March 2017. We take the transaction date, denoted as trans_date, and use the YRMO function, year-month. This returns the year and month for a date, and we select all records where the year-month is 2017-03. Finally, we tabulate to get the sum of sales and number of transactions. Within the tabulation, which uses the taboo tag, we have two tcall entries. The first computes the sum of the xSales field, while the other takes the unique count of transaction IDs. The unique count gives us the number of transactions. Let's walk through how a user would perform this analysis. First, the user chooses a table and selects all rows for store 108. The platform computes, displays, and caches the results. When a user performs another step in this analysis, they can use caching and don't need to recompute the row selection. With caching, you can most efficiently operate the trillion-row spreadsheet. The user now adds another step, selecting on March 2017. The platform computes the result using the cache from the previous step. There are now two results in the cache, one for the first row selection and one for the two selections together. Next, the user does tabulation to aggregate the results. The platform computes with the cached result from the first two actions and displays and caches the new result. The first selection query is cached. The second selection query is cached. The tabulation query is cached. Any subsequent query that uses any of these three components will use the relevant cache. The same caching process occurs when queries are run via the macro language workshop, APIs, or SDKs, as caching capabilities are built into the 1010 data platform. Every query is evaluated in sequence, and intermediate results are cached. Caching provides a tremendous advantage for what-if analysis. With prior results stored, analysts set up initial conditions just once and then probe data for different scenarios. For each what-if scenario, the platform computes only query aspects that changed so analysts can build an intuitive analysis. This is the essence of the trillion-row spreadsheet. The platform can support the development of any application that includes incremental ad hoc analysis. Caching is strict. As it's dependent on the table in use, queries are not viewed as the same when they operate on different tables. Caching is also order dependent, so queries aren't considered the same when selection ordering is different. In many cases, swapping the order of two operations can create a completely different result. Any change to the query code, even if it doesn't change the result, will not use the cache. For example, the first query here is not recognized as the same as the second, as we've added a format attribute in the will be column. The platform automatically caches results to queries and the intermediate prefixes of each query. Subsequent queries can use these cached results, but only if they are exact matches to a query in the cache.